In this example of SpaceClaim, we'll walk through the cleanup of an STL file to get it ready for printing. Now, first of all, there's a diagnostic feature, check mesh button. That'll look for things like openings in the model or inverted normals. And next, there's an auto fix button, which finds all those problems and repairs them with one button click. So it's a very fast way to make sure that your mesh, that your STL is now watertight and ready for printing. Now, you may want to stop there and print the model, or you may want to do some optimization, namely getting rid of some material on the inside. The shell tool is a great way to do this. Now, keep in mind this is a rather complex set of surfaces coming together, and a pure shell of a solid geometric model may not really be that possible, but a mesh file, it's extremely simple to do. That shell tool easily hogs away as much material as you want from the inside. Now, you may want to create some kind of a plug or an opening on the model with which you could get the material out of after printing. That's exactly what I'm doing here. Simply making a cylinder, moving it to a key location, a strategic location, and then using a subtract feature. It's much like the combine tool in SpaceClaim, but it now works with STL files. So there's a nice hole in the model that gets rid of everything on the inside, that will remove all the material on the inside. Now, you may not want to stop there either. You may want to create some kind of a plug in the model, some sort of a removable feature that you could put back in and seal the model up completely. I'm adding a different cylinder this time, a different location. It's a bit bigger, and my plug will be a little bigger than the opening was before. Now, similarly, I need to use some Boolean tools. This time, instead of subtracting material, I want to create the plug using an intersect tool. Now, I'm going to hide the solid in the original mesh, and there's that intersection. That's going to be my plug that I'll use to finish off with. A copy and paste operation keeps a duplicate for me. I'm making a duplicate because I need my opening to be a little bit bigger. And if I take that duplicate and shell it to the outside, not just the inside shelling, but the outside, maybe a small amount, and then use that to trim material away from the original body, that's going to give me an opening of an adequate size. So one last operation of these Boolean tools, this time we'll be using the subtract tool, and that does trim away material from the large blue STL body. It trims it away, but it still keeps a separate body there. We don't automatically delete it. That's really up to you to decide. There's a separate all pieces button that breaks up those STLs into different segments. Now that they've been separated, I delete the smaller one and I'm left with just the plug and the large body. It will change the color so it becomes a bit more obvious what's going on. Now, going back into a cross-section mode, it's simple to zoom in and see exactly that roughly 1/4 of a millimeter offset that I created between the two bodies. And from that point, you're free to print these out, and you have two separate bodies, and you could move them up and down and see what the interference looks like between the two. So thank you very much for watching.